minus J 1.3 minus J, this is equal to 0. So what I say to do is just multiply this out, rewrite it as a single complex number, and then you do the same thing. You take it to the other side and then find the its fourth roots. Okay, so when you multiply the j with 1.3, you get x to the power of 4 minus 1.3j, and then j times minus j, that is positive j squared, and positive j squared is equal to negative 1. This is what you get. Then this complex number over here, you need to take it to the other side, and then you'll have x to the power of 4. This is equal to 1 plus 1.3j. Now remember to use De Moivre's theorem. It has to be, sorry, let me see. Okay, it's coming back now. So to use De Moivre's theorem, your complex number must be in polar form. So you need to convert this 1 plus 1.3j into polar form. Now to do that, all you need to do is work out what is r and what is theta. Now this complex number, when I draw it here, you can see the x is positive, the y is positive, so that means it is in the first quadrant. So I don't need to work out alpha. My angle theta is the reference angle itself. So r, the usual formula, this is 1 squared plus 1.3 squared, and this on your calculator you should get the square root of 2.69. So I just left it like that, so you can finish that off and tell me what you got. Okay, and then theta, this is just tan inverse of y divided by x. Now y, hold on, somebody wants to enter the classroom. Okay, get in. Right, so this is just tan inverse of 1.3, so it's 1.3 divided by 1, which is just 1.3, and I got 52.4. Okay, so now I have my r and theta. I can rewrite this. So I have x to the power of 4. This is equal to the square root of 2.69, and then my angle is 52.4 degrees. So remember, with this De Moivre's theorem, it doesn't matter whether your angle is in degrees or radians, it works either way. But the next one we will do, it is a must that your angle must be in radians. So we have x to the power of 4. Now to find the first solution, x0, I take the fourth root, so this is 2.69. I take the fourth root of this one, and then I say 52.4 plus 0, because that's 360 plus 0, and then I divide this by 4. So my first solution, I will get 1.132, and my angle over here is 13.1 degrees. So I leave it to 1 decimal place because it's in degrees. And then the other solutions are not difficult to get. Remember, I said that there are 4 solutions. It's here, there are 4. I'm taking the fourth root, there are 4 solutions. So the difference in the angles must be 90 degrees. That 90 degrees, I get it by saying 360 divided by 4. Okay, so the second one, you just punch it in on your calculator. Your r to the power of 1 over n remains the same. And then the angle here, I add 90 degrees, get 103.1 degrees. Then the next one, x2, I get the same r, and I add 90 degrees. And then the last one, I add another 90 degrees. I have 283.1 degrees. So those are my 4 solutions. They are all 90 degrees away from each other. Okay. So today we then move on to exponential form. Try and move this. Okay, so today we look at exponential form of a complex number. So far we said that you can have a complex number in rectangular form. This is in the form a plus bj. This is your complex number z. Then we said there is also polar form. Now polar form, what I need to see is r and I need to see theta. So we've written it in short like this, z. You will also see r cos theta plus j sine theta. That is polar form, as long as I can see my modulus and the argument. And then also